So I found the interview question um, when I labeled my video, my last video's coding interview. It got a lot of hits. So I think that's what everyone is looking for, and I'll be sure to label my videos that time and focus on that. So as far as here, what to expect in the technical questions, listen carefully. Um, Look for clues in the interview, in the question itself, word for word. Many times you can't solve a problem, it's because, or you can't write an algorithm, it's because you missed a word, some key in the sentence. Draw an example. So it says here, number 2, draw an example. An example can dramatically improve your ability to solve an interview question, and yet so many candidates just try to solve the question in their heads. Yeah, so very good example is, the same thing as like write things down. Don't try to do everything in your head. Get used to writing and solving problems on paper. The worst thing to do, many times in many situations, and the worst way to learn in many situations is to just try to do everything in your head. The first thing that's going to happen is you'll forget. People have a short-term memory, and that's the way people are designed. And so that's why you need to write things down so you can solve things better. So I noticed that I forgot all about this, that I had this on. And I got to page 93, which is The Offer and Beyond, part 8. And looks like I'm about right here somewhere. Part 8 here, yeah. So we've got, I guess we got past all of this, the interview process, behind the scenes, special situations before the interview, behavioral questions, big O, technical questions. And what I've learned from this is that the coding interview comes down to, the most important thing is knowing algorithms and optimizing the algorithm. So you start off with, and they call this BCR, I believe, best case possible, or something like that. And as long as you have thought of the best case possible, that's what the goal of the software engineer is, and the goal of the interview. So what you're really doing is you're starting off with making something called brute force algorithm, which means that whatever problem they give you, you think of a way to code it, an algorithm to code it, whatever way you know how to code it, and that could be the simplest way, the fastest, easiest way that comes to your mind. That's going to be called the brute force method. What you want to do with that, the whole purpose of software engineering and also an interview, is to optimize the brute force. So you make a brute force for a problem, then the next thing is to think of better algorithms that can optimize, better algorithms, and then replace the brute force with those algorithms. And you can do it piece by piece until you have completely gotten to a best case, which is reflected by the big O analysis. And for the runtime, for the time complexity, and also the space complexity, but at least for the runtime. That is really what software engineering is about: is finding the best case, the best algorithms to use for that particular problem. And that's what optimization is. So now I'm past the technical questions. That's essentially what has happened to this point, and now I'm at the offer and beyond. So the first parts of these books right here These first parts was explaining all of that, and I haven't gotten into any problems yet. Dissecting actual coding. There was some coding lines, but not a lot. And so again, the emphasis. This book emphasized that solving the problems, the algorithms, and the optimizing is algorithms and for algorithms is the key part of this, and it's not the languages, although there are a few caveats on the language itself. When you're writing, it should be very readable for other people. It should be flexible. Written like in variables, not hard coded to specific values, integer values, and what was another one? There was one other one, but anyway, there, it seems that the industry is always more concerned about the same thing, which is algorithms and optimizing algorithms, solving problems with those algorithms more than they are about languages. The languages are secondary, and it's expected actually that you can use your preferred language, but it's expected that you can adapt to using other languages but that's always secondary. The primary skill required is the ability to solve problems using various algorithms, and the ability to do that, and also optimize that. Obviously, there will be. They do expect a person not to be perfect. They do expect that there will be errors, so they do not expect flawlessness. In fact, this person said, this writer said that in their career of interviewing thousands of Google applicants, only one was perfect. Most of them had mistakes. So the point is that there's a relative comparison to that applicant to other applicants, the performance to other applicants. So no one's perfect, but it's also a relative competency that is always made. So on a better note, actually here, this chapter, The Offer and Beyond, the news, it sounds like the recruiters, as long as you know your stuff and you can pass the technical questions, when you get to the offer itself, it seems that people are very agreeable, and you can very easily ask for more, much more than their offer, and there's a lot of negotiation. So in my opinion, this is very good news. It's always, getting into the tech companies is always about passing the interview. And obviously that big part, most of that is about the technical questions, passing the technical questions. So again, we've already reviewed that. That's about the optimizing the algorithms, using better algorithms than the brute force, the initial one. And so that's what we will continue to look at, what I will continue to look at. Even after a person is hired, they should use, that will always be the focal point to getting the next job. You have to pass the interview again, go through the same thing again. So it's always going to be that point, that same thing. So again, as far as networks, like I said, building networks leads to jobs. So and keeps you in the job market. So active in connections equals active in the job market. So that's why I think, as far as coding projects, I would prefer to take stuff that is within my local network region. So I know I live in Silicon Valley, actually. For example, we have a lot of meetups, and so I can socialize within that network, that meetup network, and take projects, offer to work on projects for free within that network. So I kill two birds with one stone. They also say, if a company rejects you, make it part of your network, thank them, and Perhaps at a later time they will return to hire you. You never know. The initial contact, even if it's a rejection, could possibly lead to a second contact, which is a hire. Um, but yeah, killing two birds with one stone. Taking out, doing the projects that are within the local network um, of friends, of colleagues. Um, I think this is a very good idea, and this is a very good proof to future employers too, especially that are within that region, also in that geographic region, um, because it's direct. It's a direct physical proof of your already pre-existing participation in that in their industry. So, and right off into bit vectors there, got a little bit off track. Just a few minutes for this. So, what is a bit vector? Um, Looks like it's an array made of ones and zeros. Um, and similar to making my own data structure. So this is one thing that is possible. Um, Making my own data structures if not if a current data structure is not useful. Uh, but I'm going to keep that in mind. But I think that will be less of application. Yeah, so again, right here it's describing the bit vector. Bit vector is an array that compactly stores Boolean values by using an array of ints or another data type, like a string. Each int represents 32 Boolean values. Yeah, even though it's explaining it, and I also asked Gemini here um, for a little more explanation, but I still can't. It's still kind of a little bit not clear. So maybe a video tutorial would help that. Maybe some visual help from Wolfram or Wikipedia. Uh, Maybe just images. That doesn't really help. Okay, let me see if I can get some. So like I said, I got on the bit vector tangent, but definitely looks like it's just either a 0 or 1, and so this 32, the 2 means it's 0 or 1, and 32 spaces in the array, 32 elements in the array. So that would be 32 bits, which gives 4 billion combinations or distinct integers that can be represented. So 2 to 32, I'd have to test that if how many combinations that creates 4 billion. Check that. So that is correct here. 2 to 32 is 4.2 billion. And that's saying that's the same as GB, so 4.2 GB gigabytes, which can fit in an 8 GB slot, 8 GB RAM. So this is a makeshift data structure that we can make. It's a binary data structure that can represent 4 billion values, 4 billion integers. And the point of making this is to reduce time, to reduce big O. And so now what they're talking about is decreasing the block size for this function. But what I want to do is confirm that I'm correct, that the reason to make this custom data structure is to minimize the big O, which is mostly runtime. So here's space complexity, reducing space complexity here, and continual suggestions to use big vector, create a big vector class. Looking at this bit vector, it has a purpose, but I'm not sure if it's time complexity. It seems that it's more space complexity related. In that case, a bit vector is likely to be used after the time complexity is determined, simply to improve the space complexity. And in that case, it will not be my primary concern. Time complexity or runtime is more of my primary concern. So optimizing algorithms focused on time complexity, optimizing time complexity.